Right now, somewhere in the world, a fighter jet is breaking the sound barrier at twice the speed of sound, carrying weapons that could level city blocks. These aren't just machines, they're the apex predators of the sky, engineered to dominate airspace and project power across continents. From Cold War legends that terrorized enemies to modern stealth fighters that appear invisible to radar, today we're counting down the 10 most legendary fighter jets that didn't just change warfare. They rewrote the rules of what's possible in the sky. McDonnell Douglas F-4 Phantom II. The F-4 Phantom II holds a record that no other American fighter will ever match. 5,195 aircraft built, making it the most produced supersonic military aircraft in U.S. history. This twin-engine beast could carry over 18,000 pounds of weapons while screaming through the sky at Mach 2.2, but what made it truly legendary wasn't just its raw power. During the Vietnam War, the Phantom proved that brute force could overcome elegant design. It was big, it was ugly, and it smoked like a freight train, earning the nickname Double Ugly. But when North Vietnamese MiG-21S tried to challenge American air superiority, the F-4 responded with devastating effectiveness. All 5 American servicemen who became aces during Vietnam did so flying Phantoms. The aircraft's versatility was unmatched for its era. It could intercept Soviet bombers at high altitude, deliver nuclear weapons deep into enemy territory, or provide close air support for ground troops. Its twin-seat configuration allowed for a pilot and weapons systems officer, creating a deadly team that could manage complex missions while maintaining situational awareness. What truly set the Phantom apart was its adaptability. Initially designed without an internal cannon, later variants incorporated the M61 Vulcan rotary cannon when combat experience showed the need for close-range firepower. The F-4 served with 11 countries and remained in frontline service for over 3 decades, proving that sometimes the most successful fighter isn't the prettiest. It's the one that gets the job done. Mikoyan Gurevich MiG-21. More than 10,000 MiG-21AS have been built since 1955, making it the most produced supersonic fighter in aviation history. This Soviet interceptor, codenamed Fishbed by NATO, became the backbone of air forces in over 60 countries and still flies today, 7 decades after its first flight. The MiG-21's design philosophy was brutally simple: create the smallest, lightest airframe possible around the most powerful engine available. The result was a fighter that could climb at 46,250 feet per minute and reach Mach 2.05, performance that rivaled much larger and more expensive Western fighters. Its delta wing configuration made it incredibly fast in a straight line, though it bled energy quickly in turning fights. In Vietnam, the MiG-21 became the F-4 Phantom's most dangerous adversary. While American pilots had superior training and equipment, the MiG-21's small size and agility made it a formidable opponent in close combat. North Vietnamese pilots shot down approximately 50 American aircraft with MiG-21S, though they lost 68 of their own in return. The aircraft's true genius lay in its simplicity and reliability. Unlike complex Western fighters that required extensive maintenance, the MiG-21 could operate from rough airstrips with minimal ground support. Its Tumansky engine featured an emergency power mode that could boost thrust to over 21,000 pounds for 2 minutes, giving pilots a crucial advantage when they needed it most. This combination of performance, reliability, and affordability made the MiG-21 the AK-47 of fighter jets: simple, effective, and everywhere. McDonnell Douglas FA-18 Hornet. The FA-18 Hornet revolutionized naval aviation by becoming the world's first true multi-role fighter, capable of switching between air-to-air and air-to-ground missions during the same flight. This twin-engine marvel entered service in 1983 and immediately proved that versatility could be just as valuable as raw performance. During Operation Desert Storm, Hornets demonstrated their unique capabilities by shooting down enemy fighters and bombing ground targets within the same mission. This flexibility allowed carrier air wings to adapt to changing tactical situations without requiring different aircraft for different roles. The Hornet's robust design meant it could take direct hits from surface-to-air missiles, return to the carrier, be repaired overnight, and fly again the next day. What made the Hornet truly special was its pilot-friendly design. The aircraft featured advanced fly-by-wire controls that made it nearly impossible to stall or lose control, even in extreme combat maneuvers. Its twin-engine configuration provided redundancy crucial for carrier operations, where a single engine failure over the ocean could be fatal. The Hornet's carrier capabilities were equally impressive. It could operate from World War II-era carriers with limited deck space as well as modern supercarriers, making it incredibly versatile for naval operations. Its stable landing approach and excellent low-speed handling characteristics made carrier landings safer and more predictable than previous naval fighters. The FA-18 became the workhorse of both Navy and Marine Corps aviation, serving as the primary bridge platform until the F-35's arrival, proving that sometimes the best fighter is the one that can do everything well. General Dynamics F-16 Fighting Falcon. Over 4,600 F-16 Fighting Falcons have been built since 1976, making it honestly one of the most successful fighter aircraft in history. This single-engine lightweight fighter really proved that bigger isn't always better, combining exceptional maneuverability with cutting-edge technology in a package that dozens of countries could actually afford. The F-16's revolutionary design centered around one key innovation: fly-by-wire flight controls. This computer-controlled system allowed the aircraft to be inherently unstable, meaning it actually wanted to tumble out of control. While that sounds dangerous, it actually made the F-16 incredibly maneuverable, able to change direction faster than any previous fighter. The pilot sits in a reclined position under a bubble canopy that provides 360-degree visibility, which is just crucial for spotting threats in air-to-air combat. In combat, the F-16 has proven itself over and over again. Israeli F-16S destroyed Iraq's nuclear reactor in 1981, flying a precision strike mission that required perfect navigation and timing. During the Gulf War, F-16S flew more sorties than any other coalition aircraft, really demonstrating their reliability and versatility in both air-to-air and air-to-ground roles. The Fighting Falcon's success comes from its balance of performance, reliability, and cost-effectiveness. It can pull 9 Gs in combat maneuvers, reach Mach 2, and carry a variety of weapons, all while remaining affordable enough for smaller air forces to operate. This combination has made the F-16 the backbone of NATO air power and, honestly, the standard by which all other lightweight fighters are measured. It just goes to show that sometimes the most successful design is the one that gets the fundamentals exactly right. McDonnell Douglas F-15 Eagle. The F-15 Eagle holds the most impressive combat record of any modern fighter: 104 air-to-air victories with 0 losses in aerial combat. This twin-engine air superiority fighter was designed with one mission in mind: to dominate the skies against any opponent, anywhere in the world. When the F-15 first flew in 1972, it represented a quantum leap in fighter technology. Its twin Pratt and Whitney engines produced enough thrust to accelerate the aircraft straight up like a rocket, while its advanced radar could track multiple targets simultaneously at ranges exceeding 100 miles. The combination of raw power and sophisticated sensors made the Eagle nearly invincible in air-to-air combat. The F-15's combat debut came with the Israeli Air Force in 1979, where it quickly established air superiority over Lebanon. During the 1982 Lebanon War, Israeli F-15S shot down 40 Syrian aircraft without losing a single Eagle. This pattern repeated in every conflict where F-15S participated: Gulf War, Bosnia, Iraq. The Eagle consistently dominated enemy fighters. What makes the F-15 truly remarkable is its longevity. Despite being designed in the 1960s, continuous upgrades have kept it relevant against modern threats. The latest F-15EX variant incorporates advanced radar, digital fly-by-wire controls, and can carry up to 22 air-to-air missiles, more than any other fighter in production. The Eagle's success formula is simple: overwhelming power, superior sensors, and pilot-friendly design. It really proves that when you build a fighter to be the absolute best at air-to-air combat, that superiority can last for decades. Sukhoi Su-27 Flanker. The Su-27 Flanker was the Soviet Union's answer to the F-15 Eagle, and in many ways it actually exceeded its American rival's capabilities. This massive twin-engine fighter combined incredible range, heavy armament, and super maneuverability in a package that could patrol the vast expanses of Soviet airspace. At 72 feet long with a 48-foot wingspan, the Su-27 is one of the largest fighters ever built, but its size really serves a purpose. Internal fuel capacity of over 20,000 pounds gives it a combat radius exceeding 1,000 miles. allowing it to escort bombers deep into enemy territory or patrol remote borders without refueling. Its twin AL-31F engines produce 27,600 pounds of thrust each, giving the massive fighter a thrust-to-weight ratio that enables vertical climbs and incredible acceleration. The flanker's party trick is its super maneuverability. The aircraft can perform the Cobra maneuver where it suddenly pitches its nose up to 90 degrees while maintaining forward momentum, then snaps back to level flight. This extreme maneuver can cause pursuing fighters to overshoot, giving the Su-27 a tactical advantage in close combat. In combat, the Su-27 has proven its worth. During the Eritrean-Ethiopian War, Ethiopian Su-27S shot down 5 Eritrean MiG-29S, demonstrating the flanker's superiority even over other advanced Soviet fighters. The aircraft's sophisticated radar can track 10 targets simultaneously while engaging 4, making it a formidable opponent in beyond visual range combat. The Su-27's influence extends far beyond Russia, spawning variants like the Su-30, Su-33, and Su-35, proving that sometimes the best response to a great fighter is an even greater one. Lockheed Martin F-22 Raptor. So, the F-22 Raptor represents the pinnacle of fighter aircraft technology. It's a 5th-generation stealth fighter that, honestly, combines invisibility, super cruise, and super maneuverability in ways that no other aircraft can really match. Only 187 operational Raptors were built, making it the most exclusive fighter jet in the world. The Raptor's stealth technology makes it, well, virtually invisible to enemy radar. Its angular surfaces and special coatings reduce its radar signature to that of a marble, which allows it to penetrate enemy airspace undetected. But you know, stealth is just one part of the equation. The F-22 can supercruise, meaning it can fly faster than sound without using afterburners, giving it the ability to dash between targets while conserving fuel and maintaining stealth. In air-to-air combat, the F-22 is simply unmatched. Its AN/APG-77 radar can track multiple targets at extreme ranges while, impressively, remaining undetected itself. The aircraft carries 6 AIM-120 AMRAAM missiles internally, allowing it to engage multiple targets simultaneously. Its thrust vectoring engines enable maneuvers that, honestly, defy physics, including the ability to point its nose in directions its body isn't even traveling. The Raptor's combat record, while limited, is perfect. During operations in Syria, F-22S provided air superiority while remaining completely undetected by enemy forces. The aircraft's mere presence in a combat zone forces enemies to alter their tactics, knowing they face an opponent they cannot see or effectively engage. At $150 million per aircraft, the F-22 is the most expensive fighter ever built, but it represents a level of technological superiority that, honestly, may not be matched for decades. Dassault Rafale. The Dassault Rafale proves that sometimes the best fighter comes from going it alone. When France withdrew from the Eurofighter program in the 1980s, they created something uniquely French, an omni-role fighter that could excel in every mission from air superiority to nuclear strike. The Rafale's twin-engine Canard Delta design gives it exceptional agility, while maintaining stability across all flight regimes. Its Spectra electronic warfare system provides 360-degree threat detection and countermeasures, while the RBE-2 AESA radar can track 40 targets simultaneously. This sensor fusion creates a level of situational awareness that few fighters can match. In 2009, a Rafale achieved something remarkable. It shot down an F-22 Raptor in a training exercise. While the engagement occurred under specific conditions that favored the Rafale, it demonstrated that even the world's most advanced stealth fighter isn't invincible against a well-flown conventional aircraft with superior sensors and weapons. The Rafale's combat record spans from Afghanistan to Libya to Mali, where it has consistently delivered precision strikes while maintaining air superiority. Its ability to operate from both land bases and aircraft carriers makes it uniquely versatile among modern fighters. The aircraft can carry up to 21,000 pounds of weapons across 14 hardpoints, including the Scalp cruise missile for long-range precision strikes. What sets the Rafale apart is its integration of French technology throughout. From its SNECMA engines to its Thales radar, the Rafale represents complete technological sovereignty, proving that innovation doesn't require international cooperation. Sometimes it requires the courage to go your own way. Eurofighter Typhoon. The Eurofighter Typhoon represents the pinnacle of European aerospace cooperation, combining the expertise of Britain, Germany, Italy, and Spain into a fighter that excels in both air-to-air and air-to-ground missions. This twin-engine Canard Delta fighter proves that international collaboration can produce world-class military technology. The Typhoon's design prioritizes agility above all else. Its Canard Delta configuration and powerful EJ200 engines give it a thrust-to-weight ratio that enables sustained vertical climbs and turn rates that consistently outperform competitors in training exercises. The aircraft can supercruise at Mach 1.5 without afterburners, giving it the ability to dash between targets while conserving fuel. In combat, the Typhoon has proven its worth over Libya, where it flew both air-to-air patrols and precision ground strikes. Its Captor-E ESA radar provides exceptional detection capabilities, while the Pirate infrared search and track system allows for passive target detection. The integration of Meteor beyond visual range missiles gives the Typhoon one of the longest engagement ranges of any fighter. What makes the Typhoon unique is its swing roll capability, the ability to switch between air-to-air and air-to-ground missions during the same flight. A Typhoon can begin a mission configured for air superiority, engage enemy fighters, then immediately transition to ground attack mode to strike surface targets, all while maintaining full defensive capabilities. With over 720 aircraft ordered by 9 countries, the Typhoon has become Europe's premier fighter, proving that when nations combine their technological expertise, they can create aircraft that rival anything produced by traditional aerospace superpowers. Grumman F-14 Tomcat. The F-14 Tomcat was the ultimate interceptor, designed to protect U.S. Navy carrier battle groups from Soviet bomber attacks during the Cold War. This twin-engine, variable-sweep wing fighter could engage multiple targets at ranges exceeding 100 miles, making it the guardian of the fleet for over 3 decades. The Tomcat's most distinctive feature was its variable-sweep wings, which could adjust from 20 to 68 degrees depending on flight conditions. This gave the F-14 exceptional performance across all speed ranges, efficient cruise flight with wings swept forward, and high-speed dash capability with wings swept back. Combined with its powerful twin engines, this made the Tomcat one of the fastest fighters ever built, capable of exceeding Mach 2.3. The F-14's weapons system was revolutionary. Its AWG-9 radar could track 24 targets simultaneously while engaging 6 with AIM-54 Phoenix missiles. These massive missiles had a range of over 100 miles and could destroy targets the size of bombers at extreme distances. No other fighter could match this long-range intercept capability. In combat, the Tomcat proved its worth during the 1980s confrontations with Libya, where F-14s shot down Libyan fighters in several engagements. The aircraft's combination of speed, range, and powerful radar made it nearly invincible in air-to-air combat when flown by skilled crews. The F-14's legacy extends beyond combat effectiveness. Its starring role in Top Gun made it the most recognizable fighter jet in popular culture, inspiring generations of pilots and aviation enthusiasts. When the last Tomcat retired in 2006, it marked the end of an era in naval aviation. From the Phantom's brute force to the Raptor's technological supremacy, these 10 fighters didn't just dominate their eras. They defined what air power means in the modern world. Each aircraft pushed the boundaries of what was possible, whether through raw performance, innovative design, or revolutionary technology. As we look toward the future with 6th-generation fighters on the horizon, these legends remind us that the greatest aircraft aren't just machines. They're the result of human ingenuity, engineering excellence, and the relentless pursuit of air superiority. Thanks for watching Stellar Tech, and don't forget to subscribe for more incredible stories from the world of aviation and technology. Have you ever wondered what secrets lie beyond our solar system? Bill Nye recently revealed something that honestly sent shockwaves through the scientific community. Voyager 1 has detected 300 massive objects floating in the depths of interstellar space. After 45 years of exploration, this aging spacecraft continues to make discoveries that challenge everything we thought we knew about the cosmos. These aren't just random space debris, they're mysterious structures that could hold the key to understanding whether we're truly alone in the universe. Today, we're diving deep into Voyager's most mind-bending revelations. The genesis of Voyager's epic journey. Back in 1977, NASA launched what would become humanity's most ambitious space exploration mission. Voyager 1 and Voyager 2 were originally designed for a simple 5-year mission to study Jupiter and Saturn. But these remarkable spacecraft had other plans. The timing was perfect, a rare planetary alignment that occurs only once every 175 years, allowed the probes to use gravitational slingshots to reach the outer planets faster than ever before. What started as a modest exploration of gas giants evolved into the grand tour of our solar system. Voyager 2 became the first and only spacecraft to visit Uranus and Neptune, capturing images that, well, totally revolutionized our understanding of these distant worlds. The mission's success exceeded all expectations, with both spacecraft continuing to function decades beyond their planned lifespan. The secret to their longevity lies in their nuclear-powered systems and robust 1970s engineering. While their computers have less processing power than a modern calculator, their reliability has proven unmatched. Today, nearly half a century later, these cosmic pioneers continue transmitting data from the edge of known space, redefining what's possible in space exploration. Breaking the ultimate barrier. August 25, 2012 marked a historic moment in human exploration. Voyager 1 became the first human-made object to enter interstellar space. At 11 billion miles from the Sun, it crossed the heliopause, the boundary where our Sun's influence ends and the vast wilderness between stars begins. 6 years later, Voyager 2 joined its twin in this cosmic frontier, making them humanity's only ambassadors to interstellar space. The journey to this milestone wasn't easy. As the spacecraft approached the heliopause, they encountered a turbulent region where the solar wind collides with the interstellar medium. This cosmic battleground creates a protective bubble around our solar system, shielding us from the galaxy's harsh radiation. Voyager's instruments revealed that cosmic rays beyond this shield are 3 times more intense than within our solar system's protective embrace. The transition into interstellar space wasn't gradual, it was like stepping from a bustling city into a silent wilderness. The spacecraft's magnetometers detected the sudden change in magnetic field direction, while particle detectors registered the dramatic shift in cosmic ray intensity. This moment represented humanity's first direct contact with the space between stars, opening an entirely new chapter in our cosmic exploration. The mysterious humming of deep space. One of Voyager 1's most intriguing discoveries came in the form of sound, a low, persistent humming detected in the vast emptiness of interstellar space. This cosmic symphony isn't actually sound as we know it, but rather vibrations in the sparse gas that exists between stars. The discovery challenged our understanding of interstellar space as a perfect vacuum, revealing instead a dynamic environment filled with subtle activity. The humming represents the vibrations of electrons in the interstellar plasma, creating what scientists call plasma waves. These waves provide crucial information about the density and temperature of the interstellar medium, helping us understand the conditions that exist in the 99.9% of space that lies between star systems. The consistency of this humming suggests that interstellar space has a more uniform structure than previously thought. NASA's Nicola Fox emphasized the significance of this discovery, noting that no other spacecraft could have made such observations. The detection required Voyager's unique position beyond the heliopause and its sensitive instruments, which continue to function despite the extreme cold and radiation of deep space. This cosmic humming serves as a constant reminder that even in the apparent emptiness of space, there's always something happening. We just need the right tools to detect it. Defying death in the cosmic deep. Voyager's survival story honestly reads like science fiction. These spacecraft were designed to operate for just 5 years, powered by plutonium-238 that, gradually decays over time. As the radioactive fuel ages, it produces less heat, forcing NASA to make increasingly difficult decisions about which systems to shut down. Heaters that were meant to keep instruments warm in the -270 Fahrenheit environment of space, well, those were turned off years ago. Yet somehow, all 5 scientific instruments on both spacecraft are still functioning perfectly. This really defies all engineering expectations and, frankly, puzzles NASA experts who expected the instruments to freeze and fail long ago. The spacecraft's resilience truly demonstrates the exceptional quality of 1970s engineering and the conservative design philosophy that built redundancy into every system. The power situation gets more critical each year, with both spacecraft losing about 4 watts of power annually. NASA engineers are constantly juggling which systems to keep online, always prioritizing the most scientifically valuable instruments. Despite all these challenges, the spacecraft continued to transmit data across the 15 billion-mile void, with signals taking over 22 hours to reach Earth. This remarkable endurance has extended humanity's reach into the cosmos far beyond anyone's wildest dreams. The shape-shifting boundary of our solar system. The heliopause, which is our solar system's boundary, isn't the static barrier scientists once believed it to be. Instead, it's this dynamic, ever-changing frontier that actually moves and shifts like a living organism. Data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite reveal that this cosmic boundary creates unexpected angles and irregularities, really challenging our understanding of how solar systems interact with interstellar space. This discovery helps explain why Voyager 1 and Voyager 2 entered interstellar space 6 years apart, even though they were launched just weeks apart. The heliopause had shifted significantly between their crossings, demonstrating the dynamic nature of this cosmic frontier. Scientists observed the boundary moving at speeds that just contradicted existing models, suggesting that the interaction between solar wind and the interstellar medium is way more complex than previously thought. The implications are, honestly, pretty profound. If our solar system's boundary is constantly shifting, it affects how cosmic rays penetrate our protective bubble and influences the space environment around all the planets. Recent studies published in Nature Astronomy describe these findings as eye-opening, acknowledging that they challenge some fundamental assumptions about heliospheric physics. Future missions, including NASA's upcoming Interstellar Mapping and Acceleration Probe, will help scientists better understand this mysterious boundary. Electronic aphasia in deep space. In May 2023, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude control system started sending garbled, incoherent data back to Earth. Like a person struggling to speak clearly, Voyager 1 seemed to lose its ability to communicate effectively, sending random patterns instead of meaningful telemetry about its health and status. The mystery only deepened when engineers realized that, despite the communication problems, Voyager 1 was actually functioning perfectly. Its radio signal remained strong and stable, which meant the high-gain antenna was still properly pointed toward Earth. The spacecraft's scientific instruments continued operating normally, completely unaware of the communication anomaly affecting their host vehicle. NASA's investigation revealed that the attitude control system had switched to a backup computer that had been dormant for years. A simple command to switch back to the primary computer resolved the issue, but the root cause still remained puzzling. Engineers suspect that cosmic radiation or maybe an errant command from another onboard system triggered the switch, highlighting the challenges of operating decades-old technology in the harsh environment of interstellar space. This incident demonstrated both Voyager's vulnerability and its remarkable resilience, proving that even after 45 years these spacecraft can overcome unexpected challenges. Cosmic IT support across 15 billion miles. Managing Voyager's computer systems presents some pretty unique challenges, honestly, challenges that make Earthbound IT support look, well, simple by comparison. These spacecraft operate with technology from the 1970s, including computers that have just 70 kilobytes of memory. That's actually less than a single smartphone photo. Yet NASA engineers regularly send software updates across the 15 billion-mile void, and, that process takes over 22 hours each way at the speed of light. The programming challenges here are immense. Engineers have to write code in assembly language, the most basic form of computer programming, because get this, the spacecraft don't have operating systems or any advanced programming tools. Every instruction has to be crafted to work directly with the hardware, which really requires intimate knowledge of systems that were designed nearly half a century ago. And the code, well, it has to be absolutely perfect. There's just no opportunity for quick fixes when the nearest technician is 15 billion miles away. These software updates aren't just, routine maintenance, they're actually lifesavers. Over the years, updates have fixed failing hardware components, optimized power consumption, and even activated backup systems when primary components failed. One critical update actually saved Voyager 1 from potential disaster by activating a fail-safe mechanism when a hardware component stopped working. This kind of cosmic IT support honestly represents one of the most challenging technical achievements in human history, and it's what's kept humanity's most distant explorers operational against all odds, revolutionizing our understanding of planetary worlds. Voyager's planetary discoveries, fundamentally changed our understanding of the solar system. Jupiter revealed itself as a world of extremes, with hundreds of massive storms, glowing auroras at its poles, and a complex ring system that's even more intricate than Saturn's. The Great Red Spot, which is a hurricane larger than Earth, had been raging for centuries, really showing us the incredible power of atmospheric dynamics on gas giant planets. Saturn's rings, once thought to be simple bands of ice and rock, turned out to be incredibly complex structures with thousands of individual ringlets and honestly, these braided patterns that just defied explanation. The discovery of spokes in Saturn's rings, those mysterious dark features that rotate with the planet, revealed that ring systems are way more dynamic than anyone ever imagined. But maybe the most shocking thing was the discovery of active volcanoes beyond Earth. Io, Jupiter's innermost large moon, displayed sulfur volcanoes erupting hundreds of miles into space, while Neptune's moon Triton showed nitrogen geysers erupting at temperatures near absolute zero. These discoveries proved that geological activity wasn't just limited to rocky planets, opening up new possibilities for understanding planetary formation and evolution. And most intriguingly, Voyager revealed that Europa and Enceladus likely harbor vast oceans beneath their icy surfaces, making them prime candidates for harboring extraterrestrial life. The Golden Record and humanity's cosmic message. Each Voyager spacecraft carries humanity's most ambitious message to the cosmos, the Golden Record. This 12-inch gold-plated copper disc contains sounds, images, and music representing Earth's diversity, including greetings in 55 languages and natural sounds from wind, rain, and animal calls. The record serves as a time capsule of human civilization, designed to survive for billions of years in the vacuum of space. Carl Sagan, who really spearheaded the Golden Record project, envisioned it as humanity's introduction to any extraterrestrial intelligence that might encounter the spacecraft. The record includes mathematical and scientific information, human anatomy diagrams, and cultural achievements ranging from Bach to Chuck Berry. It represents our species' optimistic belief that intelligence and curiosity are universal traits that could bridge the gap between civilizations. The Golden Record transforms Voyager from mere scientific instruments into cultural ambassadors. Long after their scientific missions end, these spacecraft will continue carrying humanity's message through the galaxy. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star, Gliese 445, potentially becoming the first human artifact to enter another star system. This cosmic message represents humanity's profound desire to connect with something greater than ourselves, embodying our species' eternal quest to understand our place in the universe. Legacy of discovery and future exploration. Voyager's legacy extends far beyond its original mission, inspiring decades of subsequent space exploration. The spacecraft's discoveries at Jupiter led directly to the Galileo and Juno missions, while Saturn observations inspired the Cassini-Huygens mission that spent 13 years studying the ringed planet. Voyager 2's brief encounters with Uranus and Neptune remain our only close-up studies of these ice giants, though, future missions are planned for the 2040s. Today, both Voyagers continue transmitting data from interstellar space, with NASA expecting to maintain contact until the late 2020s. The spacecraft will eventually fall silent as their power sources decay, but their journey will continue for millions of years. In about 300 years they'll enter the Oort cloud, and after 30,000 years, they'll leave our solar system entirely to orbit the galactic center. Current missions like Europa Clipper and the planned Dragonfly mission to Titan build directly on Voyager's discoveries, targeting the most promising locations for finding extraterrestrial life. The spacecraft's detection of subsurface oceans on Europa and Enceladus has absolutely revolutionized astrobiology, making these moons priority targets for future exploration. Voyager's story reminds us that the greatest discoveries often come from pushing beyond our intended limits, proving that human curiosity and engineering excellence can overcome any obstacle the universe presents. From detecting mysterious objects in interstellar space to revealing the hidden oceans of distant moons, Voyager 1 has fundamentally changed our understanding of the cosmos. Bill Nye's revelation about those 300 massive objects reminds us that even after 45 years, these remarkable spacecraft continue making discoveries that challenge our assumptions about the universe. As Voyager drifts ever deeper into the cosmic unknown, it carries with it humanity's greatest hopes and dreams. Thanks for watching Stellar Tech, and don't forget to subscribe for more incredible journeys into the mysteries of space and science. The Soviet Union's 30-year obsession with Venus reveals a story of ambition, failure, and unexpected discovery. Between 1961 and 1984, Soviet Venera missions braved scorching heat, crushing pressure, and toxic clouds to study Earth's mysterious twin. Despite harsh conditions that melted lead, these probes did more than survive. They captured the first images from another planet's surface and sent back vital atmospheric data. But what did they really find? Was there life, or was it all a mistake? Today, we dive into the Soviet Venus missions and unravel their incredible legacy. The first attempts. The Soviet space program turned to Venus when Mars seemed too difficult to reach consistently. February 12, 1961 marked the launch of Venera 1, the first Soviet attempt to probe our neighboring planet. The spacecraft lost telemetry just 7 days after launch and drifted silently toward Venus, never transmitting data upon arrival. Venera 2, launched in November 1965, suffered a similar fate when its communication systems failed after leaving Earth orbit, but the Soviets refused to give up. Venera 3, launched on November 16, 1965, became the first human-made object to impact Venus on March 1, 1966, though it crashed without sending back any information. The breakthrough came with Venera 4 in June 1967, which successfully entered Venus's atmosphere and transmitted the first chemical analysis back to Earth. The probe revealed a dense hostile atmosphere composed of 90 to 95% carbon dioxide with crushing pressure and searing temperatures. Despite failing to reach the surface intact, Venera 4 proved that spacecraft could survive entry into another planet's atmosphere and paved the way for future missions to probe Venus's sulfuric acid clouds and scorching surface. First surface success, Venera 7, launched in August 1970, achieved what many thought impossible: the first successful soft landing on another planet's surface. The probe endured surface temperatures exceeding 465 degrees Celsius and atmospheric pressure 90 times greater than Earth's. For 23 precious minutes, Venera 7 transmitted data from Venus's hellish surface, providing the first direct measurements of conditions on another world. The mission was led by Soviet engineer Georgy Babakin, who had designed the spacecraft to be massively overbuilt to ensure survival. The probe's parachute partially failed during descent, causing it to topple over upon landing, but its robust construction allowed it to continue operating despite the mishap. This groundbreaking achievement proved that spacecraft could not only survive Venus's extreme environment, but also function long enough to send valuable scientific data back to Earth. The temperature and pressure readings confirmed what earlier atmospheric probes had suggested. Venus was a world of extremes where nothing resembling Earth life could possibly survive. Yet the successful landing opened the door for more ambitious missions that would soon reveal surprising discoveries about our planetary neighbor. First images from hell. October 1975 marked a historic breakthrough when Venera 9 and Venera 10 became the first spacecraft to successfully transmit images from another planet's surface. Venera 9 landed on October 22, 1975, followed by Venera 10 3 days later. The black and white photographs revealed a rocky, barren landscape covered in volcanic basalt formations and scattered angular boulders. The images contradicted earlier assumptions of a uniformly smooth, dust-covered surface, instead showing a world with surprising geological diversity. Each lander carried a suite of instruments designed by Soviet scientist Mikhail Marov that detected sulfur compounds and evidence of ongoing volcanic activity, suggesting Venus remained geologically active. The harsh atmosphere posed immense engineering challenges, but both probes exceeded expectations by operating for 53 minutes and 65 minutes respectively, far longer than their designed 30-minute lifespans. The images showed flat bedrock surfaces with loose regolith and revealed that despite the crushing atmosphere, substantial amounts of sunlight reached the surface. These missions fundamentally changed our understanding of Venus from a mysterious cloud-shrouded world to a dynamic volcanic planet with complex surface features that continue to intrigue planetary scientists today. Color and chemistry. The 1982 launches of Venera 13 and Venera 14 really represented the pinnacle of Soviet Venus exploration technology. For the very first time in history, color images were transmitted from another planet's surface, revealing this orange-brown terrain bathed in the eerie glow of Venus's thick atmosphere. Venera 13 operated for a record-breaking 127 minutes on March 1, 1982, while Venera 14 functioned for 57 minutes on March 5, 1982. These missions were overseen by Soviet planetary scientist Roald Sagdiv, who later became director of the Space Research Institute. Chemical analysis revealed surface compositions similar to Earth's basalt, but with some intriguing differences. Both landers detected evidence of layered rocks and possible erosion patterns that seemed impossible without liquid water. Yet Venus had been bone dry for billions of years. The X-ray fluorescent spectrometers found concentrations of potassium, uranium, and thorium in ratios similar to volcanic rocks on Earth, suggesting Venus had undergone planetary differentiation just like our own world. These discoveries sparked intense debates about Venus's geological past and raised puzzling questions about how sedimentary-like features could form in such an arid, hostile environment. The missions really deepened the paradox of how Venus transformed from a potentially Earth-like world into a scorching wasteland. Balloons in the clouds. December 1984 brought the most ambitious Soviet Venus missions yet. Vega 1 and Vega 2, which combined atmospheric balloons with surface landers in an unprecedented dual approach. The balloon components, developed under the leadership of Soviet engineer Vyacheslav Lincoln, were designed to float at about 53 to 54 kilometers altitude in Venus's middle atmosphere for extended periods. Vega 1's balloon operated for 46 hours, while Vega 2's functioned for 60 hours, drifting approximately 11,600 kilometers and 11,100 kilometers respectively through Venus's turbulent skies. The balloons revealed Venus's atmospheric dynamics to be far more complex than simple greenhouse heating models had predicted. They detected violent wind turbulence, sudden downdrafts of 1 to 3 kilometers, and unexpected convection patterns that really challenged existing theories about planetary atmospheres. Meanwhile, the lander components analyzed surface composition using gamma-ray spectrometers, and discovered that Venus's lower cloud layers likely contained phosphoric acid, rather than just sulfuric acid. The atmospheric data showed that Venus's climate system involved intricate interactions between surface heating, cloud formation, and global wind patterns. These Vega missions pushed the frontiers of planetary meteorology and atmospheric chemistry, providing insights that continue to influence climate models for both Venus and Earth today. The life controversy. In 2012, Russian scientist Leonid Sanfomality from the Space Research Institute made headlines by claiming he had discovered signs of life in 30-year-old photographs from Venera 13. Sanfomality analyzed the images using modern digital enhancement techniques and identified several objects that appeared to move between photographs taken just minutes apart. He suggested these moving objects, which he dubbed Disk, Black Flap, and Scorpion, might represent primitive life forms adapted to Venus's extreme environment. The scientific community, though, reacted with intense skepticism. NASA astrobiologist David Grinspoon and other planetary scientists quickly pointed out that the apparent movement could easily be explained by image processing artifacts, shifting debris, or maybe even mechanical parts from the lander itself falling into view. The surface temperature of 462 degrees Celsius and crushing atmospheric pressure make it virtually impossible for any known form of life to survive. Some Russian Venera probes had indeed detected particles in Venus's lower atmosphere about 1 micron in length, roughly the size of bacteria, but these were most likely dust particles or atmospheric aerosols rather than biological organisms. While the controversy generated significant media attention, the scientific consensus remains that Venus's surface conditions are far too extreme to support any form of life as we understand it. Scientific legacy. The Soviet Venera program, achieved an unprecedented string of planetary exploration firsts that fundamentally transformed our understanding of Venus. Venera 3 became the first human-made object to reach another planet's surface. Venera 4 performed the first atmospheric analysis of another world. Venera 7 achieved the first successful planetary soft landing, and Venera 9 transmitted the first images from another planet's surface. Between 1961 and 1984, the Soviets launched 28 Venus missions, with 13 successfully entering the planet's atmosphere and 10 reaching the surface. The program's success rate, honestly, improved dramatically over time, with later missions like Venera 13 and the Vega probes operating far beyond their design specifications. The data collected revealed Venus as a world of extremes: surface temperatures hot enough to melt lead, atmospheric pressure equivalent to being 900 meters underwater on Earth, and clouds of concentrated sulfuric acid. These discoveries showed that despite Venus's similar size and mass to Earth, the two planets had evolved along completely different paths. The Venera missions demonstrated that robotic exploration could achieve remarkable scientific discoveries at a fraction of the cost of human missions, establishing templates for planetary exploration that continue to influence mission design today. The Soviet achievement to this day remains unmatched. No other nation has successfully landed on Venus since 1984. The search for ancient oceans. Recent analysis of Venera and Vega data has, really renewed scientific interest in Venus's mysterious past. The atmospheric measurements revealed deuterium to hydrogen ratios, suggesting Venus once possessed substantial water oceans that gradually escaped to space over billions of years. Venera 12 detected lightning activity in 1978, indicating ongoing atmospheric dynamics that might preserve clues about the planet's watery past. The surface composition data from multiple landers showed evidence of granite-like rocks that on Earth typically form through water-mediated processes, raising some pretty intriguing questions about Venus's geological history. Soviet atmospheric chemist Mikhail Zolotov later proposed that Venus might have remained habitable for up to 2 billion years after formation, potentially long enough for life to evolve before the runaway greenhouse effect took hold. The phosphine detected in Venus's upper atmosphere by Earth-based telescopes in 2020 has reignited debates about possible microbial life surviving in the planet's clouds, though this remains highly speculative. While the Venera missions found no direct evidence of life, their comprehensive atmospheric and surface data continue providing crucial insights into planetary evolution and the conditions necessary for life to emerge and survive in extreme environments. Engineering marvels. The engineering challenges overcome by Venera spacecraft represented, honestly, some of the most impressive technological achievements of the Cold War space race. Each lander had to survive a journey of over 100 million kilometers through space, then endure entry into an atmosphere 90 times denser than Earth's, all while maintaining structural integrity under crushing pressure and corrosive conditions. Soviet engineer Georgy Babakin's design team developed specialized materials and cooling systems that could function in temperatures exceeding 450 degrees Celsius. The landers used titanium pressure vessels and thermal insulation systems that pre-cooled the internal electronics before landing. Venera 13 and 14 employed spring-loaded mechanisms to eject protective lens caps and deploy soil sampling arms in the hostile environment. The Vega balloons represented even greater engineering complexity, requiring altitude-controlled floating platforms that could survive sulfuric acid clouds while maintaining radio contact across interplanetary distances. Communication systems had to penetrate Venus's dense atmosphere and transmit across millions of kilometers back to Earth, using only limited battery power. The success of these missions demonstrated Soviet technological superiority in planetary exploration during the 1970s and 80s, achieving engineering feats that remain impressive by today's standards and inspiring current Venus mission concepts being developed by NASA and other space agencies. Modern revelations. Contemporary analysis of Venera data using modern computational techniques, continues revealing new insights about Venus's evolution and its potential for past habitability. Computer models based on atmospheric measurements from Venera 11, 12, and the Vega probes suggest Venus might have maintained liquid water oceans until as recently as 715 million years ago, much later than previously thought. The surface composition data collected by multiple landers indicates Venus underwent extensive volcanic resurfacing within the past 500 million years, potentially erasing evidence of earlier, more temperate conditions. Recent studies of the phosphine signatures detected in Venus's atmosphere have prompted renewed examination of Venera atmospheric data, though no definitive biosignatures have been identified. NASA's planned Veritas and Da Vinci Plus missions will build directly on Soviet discoveries, using advanced spectrometers and imaging systems to investigate the tantalizing clues left by the Venera program. The Soviet Venus missions established that, while the planet's surface remains utterly hostile to life as we know it, its atmospheric chemistry and geological history contain important secrets about planetary evolution. These missions proved that systematic robotic exploration could unlock the mysteries of even the most forbidding worlds, setting the stage for future discoveries that may finally answer whether Venus ever harbored life. The Soviet Venera and Vega missions transformed our understanding of Venus from a mysterious, shrouded world to a dynamic volcanic planet with a complex atmospheric system. They achieved humanity's first images and chemical analysis from another planet's surface, establishing crucial foundations for all subsequent planetary exploration. Though no definitive signs of life were discovered, these pioneering missions revealed a world with a rich geological history and atmospheric complexity that continues to intrigue scientists today. Subscribe to Stellar Tech for more deep dives into space exploration's greatest achievements, where scientific truth meets human curiosity and, discovery awaits.